The quadratic formula. If you recall, a quadratic equation in standard form can be expressed in a very general way as ax squared plus bx plus c is equal to 0. Now, if we were to take this quadratic equation in standard form and perform completing the square, just using the variable terms, the result would be the quadratic formula. And the quadratic formula is written below. It's x equals negative b plus or minus the square root of b squared minus 4ac, all of that over 2a. Well, now let's look at solving the same quadratic equation in a variety of different ways. First, we're going to use factoring, then we're going to use completing the square, and finally we'll use the quadratic formula, and as you'll see, we'll get the same result each time. So first, with factoring, this trinomial, if it's factorable, should factor out to two binomials. And I believe x squared minus 2x minus 3 would factor as x minus 3 times x plus 1, because we're looking for two numbers that multiply and give you negative 3, but those same two numbers must add and give you negative 2. Then, using the zero factor property, we know that x minus 3 is equal to 0, or x plus 1 is equal to 0. So that would give us that x equals 3 or x equals negative 1. Therefore, our solution set would be negative 1, 3. So now let's solve the same quadratic equation using completing the square. Well, with completing the square, remember our goal is to create this perfect square trinomial. We know that 3 needs to be on the other side because it's not the last term that we would need in order to have a perfect square trinomial. So we'll add 3 to both sides, and that'll give us x squared minus 2x equals 3. Now, the next step in completing the square is to figure out, well, what term would complete the square. And so in this case, remember, we would want to take half of the middle coefficient. The middle coefficient is negative 2. So we'd like to take half of that middle coefficient and square it. Half of negative 2 is negative 1. And negative 1 squared is positive 1. So we'll add 1 to both sides. Now we'd like to take this perfect square trinomial and rewrite it as a binomial squared. So what binomial could we square to get x squared minus 2x plus 1? Well, it would have to be x minus 1. 3 added to 1 is 4. So we went through all this trouble just to get it in a form that would enable us to use the square root property. Using the square root property, we have x minus 1 equals plus or minus square root of 4. We know the square root of 4 is 2, so we get x minus 1 equals plus or minus 2. Adding 1 to both sides, we get x equals 1, or plus or minus 2. And then now we could write this in the longer form. So we know that either x equals 1 plus 2 or x equals 1 minus 2. Well, 1 plus 2 is 3, and 1 minus 2 is negative 1. So as you see, we get the same result. Now I know the thing that probably comes to mind immediately is that, well, the factoring was so much easier. Why in the world would we want to use completing the square? Well, we have to remember every quadratic expression is not factorable. And so when that's the case, then up until now we were forced to use completing the square. Completing the square works on any trinomial, whereas factoring only works on the ones that are factorable. Well, finally, let's use the quadratic formula. So when we look at the quadratic formula, the first thing we need to make sure of, as with the other methods, is that it's in standard form. It is. And we need to identify A, B, and C. So A in this case will be 1, B is -2, and C is -3. Once you identify A, B, and C, it's a matter of just substituting into the formula. So we start out with a negative of B. So that would be the negative of -2 plus or minus square root of B squared. That would give us -2 squared minus 4 times A is 1, times C, which is -3. All of this is over 2 times A. Well, when we simplify it, we get negative of -2 would give us 2, plus or minus the square root of, let's see, 2 squared is 4. And then we have -4 times 1 times -3. Well, that would give us positive 12. All over 2. So then we would get x equals 2 plus or minus the square root of 16, but the square root of 16 is 4 over 2. Well, again, we could write this in the longer form without using plus or minus. So we know that either x is equal to 2 plus 4 divided by 2, or x equals 2 minus 4 divided by 2. Well, 2 plus 4 is 6, and 6 divided by 2 would give us 3. And 2 minus 4 is -2. -2 divided by positive 2 is -1. So you can see we get the same solutions, -1 and 3. Let's solve another equation, and this time we'll just use the quadratic formula. So we have x squared minus 4x equals 1. The very first thing we need to do is to make sure that our equation is in standard form. We know standard form just means all the terms on one side and 0 on the other. So we would add 1 to both sides, and that would give us x squared minus 4x plus 1 equals 0. And now that we have all our terms on the same side, we can identify A, B, and C. So in this case, A would be 1, B is -4, and C is 1. Next, we substitute those values into the formula. So we would have x equals -b, so negative of -4 plus or minus the square root of b squared, so that would be -4 squared minus 4 times A is 1, times C, and C is also 1. and this is all divided by 2 times a. So that gives us x equals 4 plus or minus the square root of, let's see, we would have negative 4 squared, which is 16, and 4 times 1 is 4, so 16 subtract 4 would give us 12. All of that divided by 2. Now the square root of 12 can be simplified. We know that the square root of 12 can be rewritten as the square root of 4 times the square root of 3, and the square root of 4 is 2. So we would have 2 square root of 3. So we could rewrite square root of 12 as 2 square root 3. And this is all divided by 2. Finally, we know 2 is the denominator for both. So we'd have 4 divided by 2 plus 2 square root 3 divided by 2. And this would give us x equals 2 plus or minus the square root of 3. And that should be our solution set, 2 plus or minus the square root of 3. Well, that's our proposed solution. So next we would go ahead and check this. And you can see that if we would have tried to factor on this one, it wouldn't have been possible, because we would have been looking for two numbers that multiplied and gave us 1, but added and gave us -4, and so there are no two numbers that do that. So again, with the quadratic formula as well as with completing the square, you can use those on any quadratic equations. Well, let's use the positive version. So we'll have 2 plus the square root of 3 squared minus 4 times 2 plus the square root of 3. Well, let's go ahead and square 2 plus the square root of 3. We know that would just mean to multiply it times itself. So using FOIL, we would have 2 times 2 is 4, that's first. Outer would be 2 times square root of 3, which would be 2 square root of 3. Inner would be square root of 3 times 2, which would give us 2 square root of 3 again. And root 3 times root 3 would be square root of 9. But we know the square root of 9 is 3. Finally, that gives us 7 plus 4 square roots of 3. So we know that 2 plus the square root of 3 squared is 7 plus 4 square root 3. And then we would distribute -4 on 2 and root 3. So that would give us -8 minus 4 root 3. Well, we can see here that -4 root 3 and +4 root 3 would cancel out, and that would leave us with 7 and -8. And when we combine those two, we get -1. So you can see we have -1 on the left, the right was -1, so everything checks out. Let's look at one more example. Again, we're going to solve this using the quadratic equation. Again, we'd like to get our terms in standard form, so we'll add 3x and 2 to both sides, and that'll give us 6x squared plus 3x plus 2 equals 0. And now that we have our equation in standard form, we can identify a, b, and c. So a, 6, b is 3, and c would be 2. So next we substitute into the formula. We would have x equals negative b, so negative 3 plus or minus the square root of b squared, 3 squared, minus 4 times a times c. All of this over 2 times a, 2 times 6. This would result in negative 3 plus or minus the square root of 9 minus, let's see, 48, all over 12. And so from there we would have negative 3 plus or minus square root of negative 39 all over 12. And we know that the square root of negative a is I times the square root of a. So we would have x equals negative 3 plus or minus I times the square root of 39 divided by 12. Now, when we look at square root of 39, square root 39 is not a perfect square, and it doesn't have any perfect square factors. The only factors for 39 would be 1 in 39 or 3 in 13. So therefore, we would leave it under the radical as it is. So our solution set would be negative 3 plus or minus I square root of 39 all over 12. So now the fun part, the checking. So we have 6, and we'll use one of those solutions. Let's use negative 3 plus I square root 39 all over 12 squared. So of course we would have to square the numerator first. When we square the numerator, it would be negative 3 plus I square root 39 times itself. Using the FOIL method, negative 3 times negative 3 is positive 9. Negative 3 times I root 39 would be negative 3 I root 39. I root 39 times negative 3 would give us the same thing, negative 3 times I root 39. And finally, I square root 39 times I square root 39 would give us I squared. Now, root 39 times root 39 would be 39. I think we've done enough of these by now where you should be able to see that that's the case. So if we combine like terms here, we would have 9 minus 6 I square root of 39, and then I squared is negative 1, so we would have negative 1 times 39, so that would give us negative 39. Finally, combining 9 and negative 39, we would have negative 30 minus 6 I square root of 39. So we would have 6, and we know the numerator would be negative 30. Minus 6i times the square root of 39. Now all of this over 12 squared. And instead of writing this as 12 squared, let's just write it as 12 times 12. And the reason why I chose to write it that way is because we would have some cancellation there that might help us not have to use such large numbers. So we know this is 6 over 1, or 6 divided by 1. And I see a common factor of 6 between numerator and denominator. 6 would divide itself one time, and here 6 would divide 12 twice. So that would leave us with negative 30 minus 6i square root of 39, all of that divided by 24. Now before we go any further, let's go ahead and work on the other side, because remember, the whole goal is to see if these two sides come out to be the same. We wouldn't want to simplify too much, and then the other side may be the exact expression that we already have. So on the other side we have negative 3, and we're using negative 3 plus I square root 39, all of that over 12 minus 2. So here we would just take negative 3 and we could distribute it on the numerator. So if we do that, we would have negative 3 multiplied by negative 3. That would give us positive 9. And then negative 3 times I root 39 would be negative 3 I root 39. And all of this is over 12 minus 2. So we need a common denominator. Common denominator in this case would be 12. So we would have 9 minus 3i root 39 divided by 12 minus, and we know 2 is the same as 2 over 1. So if we need a denominator of 12, we'd multiply numerator and denominator by 12, which would give us 24 over 12. So now putting numerator and denominator together, we'd have the 9 and then the minus 24. So 9 from 24, 9 minus 24 would be negative 15 minus 3i root 39, all of that over 12. Now when we compare these two expressions, you should be able to see that if we were to multiply numerator and denominator by 2 on the right hand side, then you would get what's on the left hand side. Or if we were to divide numerator and denominator by 2 using the expression on the left, then we would get the same thing as on the right. So it doesn't matter which way you do it. Remember, the goal is to show that we get the same thing. So let's divide numerator and denominator by 2 on the expression on the left. So if we divide the numerator by 2, then that would give us negative 15 minus 3i root 39, and dividing denominator by 2, 24 divided by 2 is 12. So you can see we get the same expression on the left as on the right, so everything checks out.